So the ultimate goal of math for most people is to answer questions about real-world applications. So let's consider an application. After Lauren donated their hair to Locks of Love, the length, L of t, of their hair in inches was given by this function right here. L of t is equal to 1/2 t plus 17.5, where t is the number of months after having the haircut. Identify and interpret the slope and the intercept of this model. We're given this model. We called it L of t. I assume L means length of Lauren's hair. It's 1/2 t plus 17.5. So we want to identify both the slope and the intercept. Well, the slope is always the multiplier on the independent variable. What's the independent variable? Well, you look into the parentheses. Aha, independent variable is t. What's the coefficient of t? Coefficient of t is 1/2. So slope here is 1/2. I want to find the y-intercept as well. It's always a point. It's the point where the independent variable is 0. So if t is 0 in this case, what do I get? Just this 17.5. So step 1, identify, check. Step 2, interpret. Well, that takes a little more effort. The slope is a rate of change. So we want to interpret the slope as a rate of change. We might want to know what the units are in that case. Well, this is rise over run, which says change in x over change in y. In this case, L of t is our y. So changing L of t. And our x is t. What are the units on L of t? Well, let's go back and look. L of t is the length of hair in inches. Okay, so this is inches. And t is the number of months. So this is months. This tells me that my slope has units inches per month. How do I interpret this? This is how quickly, rate of change, how quickly Lauren's hair grows. It grows at a rate. Slope is a rate of change of what? Well, 1/2. 1/2 inch per month. That's how I would interpret the slope as a rate of change. I'm going to go looking for units and use those units to tell me what's going on. We also want to interpret the intercept. The y-intercept unit is always going to be the same as the units of the function. So the L of t units, the same as the dependent variable. Well, it's in inches. So this is 17.5 inches. What does that mean? Well, if it's 0, 17.5, t is 0. No time has passed since Lauren's hair was cut. How do I interpret this? I say that Lauren's hair well, that must have been 17.5 inches when it was cut. Of length or in length. Directly after her haircut, so right after it was cut. This is the length of her hair at time 0. Time 0 means right after the hair was cut. So how do I interpret the intercept? I look for the units. This is at the independent variable is 0. So in the case of time, this is time equals 0. So when we began measuring, it was 17.5 inches. I have one more example for you. This one says that a cross-country skier reaches the 3-kilometer mark of a race in 15 minutes and the 12-kilometer mark 45 minutes later. Assuming a constant rate, find the speed of a skier. So we notice immediately the word rate. Rate to me implies a slope. In fact, speed is a rate of change. What are the units on speed? Well, usually it's in kilometers per hour. This kind of tells us what our setup is going to be. If it's kilometers per hour, well, then this is my change in kilometers over my change in time. In fact, our time was given in minutes, not in hours. So we could set this up with minutes if we prefer. What's our change in kilometers? So what is the change in our distance? We started at the 3-kilometer mark and then past the 12-kilometer mark. So our change in distance was 12 minus 3 kilometers. So 9. So that is our change in kilometers. What's our change in time? Let's use minutes in this case. We can move it into hours later if we decide. Let's say we started at 15 minutes and then 45 minutes later. Okay, be careful of the wording here. It's kind of tricky. You might think, oh, I'll take 45 minutes and subtract 15, and that's my change in time. But if we read very carefully, notice it says 45 minutes later. So we measured 3 kilometers, and then 45 minutes later, we hit the 12-kilometer mark. So the passage of time has actually been 45 minutes. That's been given in the wording of the problem. To find the speed of the skier, it says take your change in kilometers over your change in hours. That's 9 over 45. That will reduce. 9 divided by 9 gives you 1. 45 divided by 9 gives you 5. Our units are kilometers per minute. 1/5 of a kilometer every minute. We can change that into hours if we want to. We can use the fact that there are 60 minutes in an hour. I come over here and just do some side work. That kilometers per minute. How many minutes in an hour? There are 60 minutes in an hour. If I want the units to cancel, they need to be diagonal from one another. So I put minutes up top here. And these will cancel. So I have 1 times 60 is 60. And then 5 times 1 is 5. 60 divided by 5 is 12. So if I want this in kilometers per hour, the speed of the skier is 12 kilometers per hour. So either one of those is correct. So that is it for section 2.3. Next time we'll be covering even more about lines. All of chapter 2 is about lines. So look forward to that.